talking about solving quadratic equations. Some of them we can solve just like a normal equation. Some of them we need a special formula because it won't be able to be solved as we might some normal equation like some of these first examples. So first at the top they want us to define what a quadratic equation is. So what is a quadratic equation, or what does it have to have for us to know that it's a quadratic? Yes, it does need three terms typically. If there's not one there, then it's understood to be zero. Good. With those three terms, one of them's a constant, right? One of them should have a term x assigned to it. To know it's a quadratic, it specifically has to have a what? What do each one of these have for the first term? A square, right? That's what lets us know it is a quadratic. Otherwise, it would be a linear equation if it didn't have a square with it, okay? So a quadratic equation is an equation that contains a square term. And an example of a quadratic is any equation that has that x squared term in it where the square is that highest exponent. So it doesn't matter what the coefficients are. You might even have a coefficient, like this one doesn't have a term of x, right? This one doesn't have a term of x. Maybe that middle term has a coefficient of 0, right? But you've got to have some x squared term in there. But typically, yes, somebody said it first, we do have all three terms, so it might look something like this. Our x squared, our x, and our constant. And we want to set that always equal to 0 before we solve, okay? All right, so in this first set of examples, they tell us to solve these three quadratic equations. Okay, in order to solve a quadratic, typically we want all three terms. We can see these do not have all three terms. In these ones, since there's not all three terms, we may just want to try and solve it like we would for x, right, in a linear equation. If that's what we're going to do, our goal is to get the x by itself, right? So we're not going to set it equal to 0. We're trying to get rid of everything that's on the same side as my x squared term. So for example, on A, what would be my first step in getting the x squared by itself? Yes. Very good. So if I subtract 5 from both sides, I'm going to end up with x squared equals x. Okay, and I'm solving for x, so now I would need to get rid of that square term. And what do we say the opposite of a square is? Right. So I would want to take the square root of both sides. Now, is there a perfect square root for 24? No. So we would have to simplify it like we talked about in last class. Okay? Something that is important for us to remember is that when you are taking the square root of a number, you have no way of knowing if the number that was squared to get this number was a positive or a negative, because we know 3 squared is 9. What about negative 3 squared? Also 9, right? So since we don't know what we started with, we don't know. Was it originally a positive or was it originally a negative? So something to keep in mind, anytime you take a square root, consider that there could be a positive and a negative answer there. We don't know, okay? All right. Now, like you guys said, there is no perfect square root of 24, so I would want to rewrite it in its simplest form using that process that we talked about last week on Friday. So remember, I think to myself, I know there's no perfect square root of 24, but is there some numbers that multiply to give me 24 in which one of them has a square root? Yes. Very good. So I could rewrite this as the square root of 4 times the square root of 6, and we know the square root of 4 is right. So really, I would have x is equal to plus or minus 2 square root of 6. Okay. And if you were to graph this one, then it is going to be intersecting or touching your x-axis in two places because you just came up with two solutions. Positive 2 square root of 6 and negative 2 square root of 6, all right? So you may make a little note over here. Touches x-axis twice. All right? Okay, so let's look at this second one here. Trying to solve for x, so what are we going to do first? Okay, it's already a negative, so we're not going to subtract it, add it, right? So I add it, and I'm going to end up with 3x squared equals what? Right. Okay, then what should we do to get x by itself? Right, so we end up with x squared equals, right? And then our last step would be to take the square root of both sides. Very good. Now again, we do want to consider a positive and negative answer. However, there's not really a positive 0 and a negative 0, right? It's just 0. So my solution here is x equals 0. So how many times would this one touch the graph? Right, the x-axis of the graph once. So it touches x-axis once. Alright. Okay, let's look at example C here. What are we doing first? So I have negative 6x squared equals, nice. And then what are we going to do? And what is 18 divided by negative 6? Very good. And then our last step here would be to take the square root. Very good. Okay. So we have a negative underneath our square root. If you type square root of negative 3 in your calculator, what does it say? Error, right? Because this isn't possible, right? Because we know that when you are taking the square root, that means at some point this was squared to get to the negative 3, right? Well, no matter what you square, whether it's two positives, negative 3 times negative 3 or negative 3 squared, you get a positive answer. Or if you square a positive number, you still get a positive answer, right? So there is no number I could have possibly squared, no decimal, anything, to get a negative 3, right? So since this is not possible, I would say that this one doesn't have a real solution, right? So square root of negative 3 is not possible. So as far as a solution goes, this one is not going to have a real solution. There are square roots of negative numbers. Those are called imaginary numbers, and we won't be talking about those just yet. Okay. So this one would still be a parabola, but that means that maybe whenever it's graphed, maybe it's up here like this, right? It's not ever going to actually touch that x-axis potentially, because it has imaginary roots, right? So this one does not touch across the x-axis. So sometimes it's nice like this, we can solve it just like we would any normal equation. Sometimes we have that third term and it's not as easy as that. So this is when you guys would have learned the quadratic formula back in Algebra 1. Does anybody remember what that formula was? Yes. Very good, yes. So we have x equals that negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay? And those a, b, and c values are your coefficients from the equation. A will always be the term that's with your x squared. B will always be your term that's with your linear x. And c will always be the constant, the term that's not with a variable. All right? Okay, if this one is not already set equal to 0, then that's your job. Do that first before you start assigning values to a, b, and c, because it might change if you have to move some stuff over. All right? So let's look at a couple of examples for this. It says, use the quadratic formula to solve the equation 8x squared equals 1 minus 6x. Okay? So, is this one set equal to 0? So first thing we're going to need to do is rearrange it or write it in standard form. We need it to be set equal to 0. Okay, so if I have 8x squared equals 1 minus 6x, and I want to rearrange this so that it's all equal to 0, how am I going to move that negative 6x to the other side? Yes. Right? And how am I going to move that positive 1? Right. So this new equation, when rewritten in standard form, would read 8x squared minus 6x, plus 6x minus 1 equals 0, right? And we do want to try and keep it in order of descending order for our exponents, just so that way we know which one's the a, b, and c. We don't make any mistakes there, okay? So then they ask us to determine which coefficients are representing the terms a, b, and c. So what's my a here? Good. And what's my b? And my c? Very good. So when we substitute that into this formula up here, this is what I'm using, right? Only the coefficients. You notice we didn't say that a was 8x squared, right? Only the 8. We only plug in the actual coefficients, no variables in this one, okay? So now it says to use the quadratic formula to find the solutions for these. So we're going to have x equals, the formula is negative b. And what's our b? Good. Plus or minus the square root of b squared, 6 squared. It's good practice to put that number in parentheses, because if it's a negative, you would have to put it in a parenthesis if you're going to type it in your calculator, right? Okay. Minus 4 times a, which is good, times c, which is good. And all of this, including that negative 6 out in front, is divided by 2a. Okay. So sometimes you can just type the whole thing in your calculator and get an answer, but sometimes you might end up with a negative underneath here, and your calculator is obviously going to tell you it's an error, right? Because you can't take the square root of a negative. Also, we know that we can now simplify these ourselves to the simplest square root form, right? So you need to make sure you simplify it to the simplest square root form before typing it into your calculator, because your answer choices on the test may have only the simplified square roots, right? So we need to practice doing that as well. All right, so we are just going to simplify what's underneath the square root first. So I'm going to copy over my negative 6 plus or minus. Underneath this radical, we're going to use order of operations, right? What is 6 squared? 36, right? So this is 36, but before I subtract, I'm going to multiply these three terms together, right? So negative 4 times 8, negative 32, and then negative 32 times negative 1 is positive. Okay, so we have 36 plus 32, which is going to give us, good, all over that 2 times 8, which is, good. All right, now we want to rewrite that square root of 68 in its simplest form. So what would multiply to give me 68? And one of those terms has a square root. Remember the trick in the calculator, if you don't know your multiplication facts for a number, you can go to y equals, type just the number divided by x without the square root, and pull up the table. Yes, you had your hand raised. You know them. Which ones are they? Oh, I thought you were raising your hand because you were going to tell me what numbers to use. Yes.
Is it 16 and 4?
Is it what?
16 and 4.
16 and 4, 16 and 4. Yes, I believe those are right. Yes, because the 4 would work. But the 68 doesn't have to have the square root. I don't have a calculator on me. Let me double check it. I think it's 17. Did you maybe mistype the number in the y equals? Just the 68? Did you type just the 68?
Oh, I had 64.
Okay, alright. I was about to say 16, 4 both have square root, so I wouldn't think that would be it. Okay, so we would have negative 6 plus or minus. Like he said, we want to use 4, but it's 17 and 4, right? And we know that the square root of 4 is what?
2.
So I can rewrite this as negative 6 plus or minus 2 square root of 17 all over 16. Okay? Because all of the numbers outside of the radicals here are even numbers, you could simplify all of those terms by 2, right? If I simplify negative 6 by 2, it's going to turn into negative 3 plus or minus 2 divided by 2 would just be 1, right? So we'd just be left with 1 square root of 17, or just square root of 17. And 16 divided by 2 would be. Okay. So I would accept either one of these answers as the simplified radical term. This one just took it that one step further, simplifying out the 2. All right. Now, if your answers are decimals, remember we can write this in decimal form by typing these terms into our graphing calculator, right? But remember, you're going to have to type it in twice, one with the plus sign in it, one with the minus sign in it. So if I was in my graphing calculator, I would do alpha y equals enter. Give it that fraction. Alpha y equals enter. And in the top of my fraction, if you're copying from this first one, would be negative 6 plus 2 square root of 17, all in the top, over 16, right? And what would our decimal answer be there? Approximately. Yes.
0.14.
Very good. So x equals 0.14. We're going to take it 3 decimal places on both, so it would end up being 0. And then I would type it in exactly like we just did, but instead of negative 6 plus that radical, I'm going to do negative 6 minus that radical. And approximately what would that one be? Yes. Very good. All right. So these would be your answers if you were to check it in your calculator. Okay. Also, you could type your equation that you had up here into y equals, and then check the solutions, and they should match these numbers as well. All right.